So, ever wondered why Earth teems with vibrant life? The secret lies in its perfect cosmic address, folks. Earth sits right in the Goldilocks zone of our solar system. Pretty cool, right? This Goldilocks zone is the sweet spot for life. It's a region around a star where conditions are just right. Not too hot, not too cold, but perfectly balanced. And so, liquid water can exist on a planet's surface. Liquid water, guess what, is the key ingredient for life. The location of this Goldilocks zone, though, depends on the star's type and its brightness level. For a main sequence star like our Sun, the habitable zone spans roughly 0.95 to 1.37 astronomical units. Earth is perfectly placed at about 1 astronomical unit. Just the right distance from the Sun for a cozy climate. With an average surface temperature of 15 degrees Celsius, it's ideal. This makes Earth a unique haven for life to thrive. We've got vast oceans stretching across the globe. Lakes, rivers, and streams flowing everywhere. These provide the building blocks for life to flourish. But here's the thing, the Goldilocks zone isn't fixed. Stars like our Sun evolve over billions of years. Their brightness and temperature slowly creep upward. And so, the habitable zone shifts farther out over time. The Sun is a main sequence star, full of energy. Over 4.6 billion years, it's grown 30% brighter. And its brightness will keep climbing in the future. This impacts Earth's ability to sustain life. Earth's prime position isn't a forever deal, you see. It's tied to the Sun's life cycle, our cosmic clock. Picture this. When Earth formed 4 billion years ago, things were different. The Sun was only 70% as bright as it is today. The habitable zone was closer, near Venus's orbit. Scientists studying Venus's rocks and atmosphere found clues. Evidence suggests it once had liquid oceans long ago. Maybe even simple microbial life. Here's the kicker. Venus might have been a promising home for life back then. But as the Sun got brighter, everything changed fast. The Goldilocks zone shifted outward, leaving Venus behind. Venus's surface temperatures soared uncontrollably, triggering a runaway greenhouse effect, a total game changer. It turned Venus into the fiery hellscape we see today, with surface temperatures hitting a scorching 460 degrees Celsius, and atmospheric pressure 92 times that of Earth's. Luckily, Earth moved into the Goldilocks zone's sweet spot, becoming the cradle for life to thrive and evolve. But the story doesn't end there. The Sun's brightness will keep ramping up. About 3 billion years ago, think about it. Earth went from a barren rock to a lively oasis, bursting with ecosystems, plants, and animals galore. Yet, the Sun's evolution marches on relentlessly. Earth's time in the habitable zone will face challenges. Let's dive into why. The Sun, a main sequence star, powers itself through fusion. Its core hosts nuclear reactions that generate massive energy. Deep inside the Sun's core, here's how it works. Extreme heat and pressure fuse hydrogen into helium, releasing colossal energy that fuels our planet. Every second, 600 million tons of hydrogen turn into helium. About 4 million tons of matter convert into pure energy, radiating as light and heat across the solar system. This is the sunlight that powers life on Earth, driving photosynthesis and sustaining ecosystems. But as hydrogen in the core gets used up, things shift. Helium builds up, making the core denser over time. Fusion slows, but the core gets squeezed tighter. To keep the balance, something's gotta give. Gravity compresses the core, raising its temperature. This boosts pressure, making the sun shine brighter. Scientists predict a 10% brightness increase every billion years. And so, the Goldilocks zone keeps drifting outward. This will directly impact Earth's climate in the long run. What does this mean for our planet's future? Here's the deal. A brighter sun means a hotter Earth. The habitable zone will slip away from our planet. In about 1 to 2 billion years, mark my words. The Goldilocks zone may shift toward Mars's orbit, or even farther, out to Jupiter's realm. spanning roughly 1.52 to 0.5 astronomical units. By then, Earth will no longer sit in the habitable zone. Rising temperatures will transform our environment. Liquid water will start evaporating at an alarming rate. Water vapor in the atmosphere will skyrocket big time. Water vapor, a potent greenhouse gas, will trap more heat, creating a vicious cycle that spirals out of control. The greenhouse effect will become unstoppable, much like what happened to poor Venus ages ago. Earth could turn into a scorching, uninhabitable world. And then, surface temperatures might soar past 200 degrees Celsius. Life as we know it would struggle to survive. This process is slow but inevitable, folks. First, polar ice caps will melt rapidly. Sea levels will rise, flooding vast coastal regions. Ecosystems will collapse under the strain. Climate patterns will shift dramatically, unpredictably. Mass extinctions will sweep across species. As moisture vanishes from the atmosphere, Earth will become a dry, barren rock. Heat and radiation will erase traces of life. But hope isn't lost in our solar system, believe it or not. The Goldilocks zone will keep drifting outward, reaching Jupiter or even Saturn's domain. Moons like Europa could become prime candidates. Europa's icy surface hides a vast liquid ocean beneath. As the sun brightens, that ice might start to melt, revealing an ocean ripe for new possibilities, opening the door for life to take hold. The cosmos is ever-changing, full of surprises. And who knows what wonders await us out there.